Hello, this is an introduction to the AIP4Win's magnitude measurement tool. To use this tool, select Measure, Magnitude Measurement Tool, and the tool will open. When the magnitude measurement tool opens, it automatically loads the observer information that was in use the last time the tool was open. In this case, the information is for BYY lions. If I want to change that to BYY PMO for Pine Mountain Observatory, I select BYY PMO, click Recall File, and the observer information for that location is loaded. In this case, I'm going to click BYY Lions and recall that because that's the information I was using for these observations. The next step is to click on the Images tab. I'm going to perform photometry on some images stored on my hard drive. I'm going to click Select Files, and I'm going to go to the Photometry directory and load BLCam full dataset. And I'm going to select, for demonstration, the first 10 files in this data. I'm going to open those. Now I have a list of files to select. There could be several hundred. And I'm going to select the first one so that I can continue selecting my stars. I'll adjust it so that I can see the field of view that I want to work with. Now we move to the Settings tab. All stars in an image like this have identical profiles and very similar curves of growth, so that I can test my star photometry settings using any star in the image. I'll simply select this one at random. This gives me a profile of the star image. I have an aperture of 6 pixels. You can see 0, 1, 2, 3, 4, 5, 6. This darker line, this heavier line, marks the outside of the aperture. 7, 8, 9, this represents the inside of the annulus, out to 15. So you can see the annulus has a low constant value, and you can see the image of the star. Most of that light is contained inside the aperture. I can now also summon up the curve of growth line. This shows me how the magnitude of the star increases as I increase the aperture. 6 is a good choice if I want to include all the light from the star. However, an interesting thing, if I look at the signal-to-noise ratio that can be derived from the star, I find that an aperture of 6 gives me a lower signal-to-noise ratio than I might expect. If we try a radius around 3.5, you can now see that I've placed the radius, the peak of the signal-to-noise ratio curve. This is the way I can get the best possible photometry on this star. Now that my settings are made, I proceed to the Stars tab. I'm doing photometry on BL Camelopardalis. That's actually this star here. I select that, recall the file, and this brings up the information, the right ascension, declination, standard magnitudes for my 2 comp stars. I simply click on BLCam, that there. C1 is this star, which I know from using the AVSO chart. Star C2 is here. And that's all there is to it. If I make an error, I click Deselect Stars, and then I select the proper stars. With the stars selected, I now move to the Report tab. The Report tab gives me the ability to select a variety of different reports. The AVSO format is probably the one that most AVSO observers would use. The Center for Backyard Astronomy report, you can get a bare bones report, which is exactly what they want. If you want to analyze your data using spreadsheet software such as Excel, you can select the text format report, which gives you a fairly rich group of choices. You can get a very bare bones report or a report of everything. The raw instrumental magnitudes will give you photometry on all the stars you select. Signal noise ratio simply gives you a report on the signal noise ratio of every star in the frame. And if you want to get your hands on all the data collected during the photometry run in Excel format, you simply can select all input values. For this demonstration, I'm going to do the AVSO format, and I'm going to select, because I was using a clear filter and I'm doing V magnitude, I'm going to use CV to report filter information to the AVSO. Having selected my report, I now move on to the Execute tab. These are bright stars, so I'm simply going to use the default recenter each star independently as the tool loads one image after another and finds those stars. It's going to use a search radius of 20 pixels in order to find those stars. And I'm going to pause 1 second between images so that the photometry doesn't occur too rapidly for me to see. Now all I have to do is to click Run Photometry, and the photometric process begins. Since these are large images, it takes several seconds to load and process them. With small images, such as 512 by 512, they'll run so quickly you can barely see them go by. There we go. Once the photometry is run, I'll find my data in the AIP4Win data log. I click on that and examine the data that I have. This is the AVSO extended format, and in this column here, this is where the magnitude of the star is recorded, 12.951, with an uncertainty of 6 millimags. Save that to a file. I simply click on Save to File and then save it under a file name. This file can then be sent to the AVSO. To recap, to use the magnitude measurement tool, select Measure, Magnitude Measurement Tool, and your observer information will pop up. Select the images you want to perform photometry on. You'll get a list of them. Select one for choosing your stars on. Check your settings. Looks good to me. Select the star. There's BLCam, C1, C2. Select the report format you want and run the photometry. When that's done, you can examine your data. Looks good. There's the changing magnitude. Save it. And if you want a quick look at the light curve, you can now see the BL cam came to a maximum and has started down again. Thank you for the opportunity to give you a quick look at how the magnitude measurement tool in AIP for Windows works.